Thanks again for reminding me. Yeah, all right, I've started it now.
Thanks, Sanjay.
Yeah. And so what you see here, I'm going to just move this. My screen has become a little cluttered because of all the things that I have open here right now. Okay, so let's connect to the AI companion. So here's the QR code. I'm going to scan it, and then whatever is here is going to momentarily appear on my phone. Okay, so there it is. And what this has is, you see all this row, you see this row of buttons on the top?
Mhm.
Yeah, so I can use these buttons to make the Android man move. So that's that Android dude is our little turtle. And I can make him move, and I have all these commands, right? I have forward, so he's moving forward. And as he's moving forward, he's drawing a line, okay? Now I press the right button, and you see the dude has turned to the right and now forward, and he keeps going. I can do pen up by pressing the up button and down. So when I do pen up and turn the dude to the right, now he's pointing downwards, forward, forward, forward. He's not drawing anything because the pen is up. Make him turn right, 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 right. Get him pointing the right direction, pen down and forward again. And so, this is as simple as it is, right? And you can use these buttons. This is one way to use the app. You just use the buttons to make the Android man draw on the canvas, okay? And then can reset and start all over again, right? And we will not be doing this, right? These buttons are already programmed. So what we'll be doing is we'll be writing code in the form of algorithms to make the Android man draw what we want drawn on the canvas, right? And in the process, we'll use the building blocks, which are the procedures. So each one of these buttons is implemented as a procedure, right? And so we'll write our code by using those already written procedures into our code, right? Into procedures we will write. And then we'll use those procedures in other procedures, and we'll build up. We'll start with very simple primitive graphics, and then we'll build up to more repetitive patterns and more interesting graphics that will make the little turtle man draw, okay? So let's get started with something very simple. So let me go to blocks now. When you look at the designer, what you have is one screen and then a horizontal arrangement which has all the buttons. So there's 6 buttons, and each one of these buttons has a procedure associated with it. So we'll see that in a moment. And then, as we have seen earlier, to draw in App Inventor, to draw in Android, in an Android app, we use a canvas and a sprite. So there's only one canvas here, and there's the Android man is the only sprite, and the notifier is there to give us some instructions. Okay. So let's get into the code and let's start looking at the procedures. And the procedures are already written, so we don't need to really focus on how these procedures work in this session, because we are just going to use them. So rather than focusing on how they work, so how does the Android man draw a line when we press the forward button? When we press the forward button, we call this procedure. From the names of the procedures, you can probably guess what they do. So here's the forward one, right? And that will also be here. So what I've done here is actually to clear up the canvas, I have minimized these procedures. They're actually rather big, right? So that's kind of why they look small. So if you look at the forward procedure, we won't focus on how it works, right? Although we can do that, what we need to know is what it does, okay? And for example, the forward procedure, as you just saw from the designer view, the forward procedure makes the Android man take one step forward, okay? How big is that step and all of that, that is already coded here in the global variables. So you can see a global dx and a global dy. So these are the sizes of the steps in the x, which is the horizontal, and the y, which is the vertical direction. So all that is already set up, okay? Pen down is true by default. So every button has an equivalent procedure. So we just looked at forward. So that will just make the man step forward. What else did we make the Android man do? I'm saying Android man, but he could equally be an Android woman. But yeah, the Android dude, let's call him that, right? So we could make him turn. So there's a procedure to turn, okay? And that'll just make the Android dude turn 90 degrees, all right? What else is there? There is a pen up procedure, a pen down procedure. So here's pen up. It will just, we are drawing on the canvas. So pen up here, there's no physical pen, but conceptually what it will do is as the Android dude moves, there will be no drawing, right? And pen down, drawing will resume. It makes sense, yeah? Pretty straightforward, right? And then there are some other procedures to reset, to clear up the canvas, to start from scratch. And there's a show and a hide turtle as well. Okay. So if you don't want to see the Android dude, we just want to see the drawing that he made on the canvas, then or she made on the canvas, then that's hide turtle and show turtle. And that is pretty much it. So each one of those 6 buttons has a procedure. Are you with me so far? Yeah. And the interesting thing is there's another button. Let me go back to, this does require going back and forth a lot. So yeah.
I have a
forward,
question.
right?
I have a question, Sanjay.
Yeah, go ahead.
These minimized blocks that you have were these are the code that you already did to make this demonstration.
That's right.
Is this okay?
That's right.
All right.
And so today our focus is on algorithms, right? So we could actually write each one of these functions in class. Some of them are fairly straightforward, others are a little more involved. But then we would spend all our time writing these procedures and we would be learning exactly nothing new, because what these procedures use concepts that we've already used in previous classes. Yeah. So feel free to look at the procedures, and if you have any question later, you can ask me. But today we'll be focusing on algorithms. And the reason a little bit of explanation about this setup today, okay? So say you're programming in Python or JavaScript, you're building algorithms, okay? You will use libraries built by other people a lot, okay? And that's how the open source, that is the open source style of programming. So other developers that are part of the community around that technology will make available procedures or objects that they have already written, mostly for free, right? For free, actually, for others to use. And so we build on code that others have written, okay? And so far we were building the foundation for programming in App Inventor. Now we are taking the next step and building the house on the foundation. And when we do that, we will almost invariably, the starting point will be code that somebody else has written. Okay, we'll take that code and we'll modify it, we'll update it, we'll upgrade it, and we'll use it in our own program. So that is the setup for today's exercise. Makes sense? Yeah. Yeah, and of course you are free. I share this code in the Google Classroom. So anytime you feel like looking at the code and understanding better how it works, you can always just ask me about that. Just coming back here. Are you guys still there?
Yes.
Okay. So there's a draw button, right? And what does a draw button do? So right now, if I click it, it drew something. Actually, let me reset that. And yeah, let me go back to the draw method. And that's because the draw button has this draw procedure that's driving it. And in this procedure, we are expected to enable block. Yeah. So in this procedure, we can customize what we want the Android man to do. Okay. So we'll be using these basic building blocks that are already nicely there for us, right? We'll be using these building blocks to do more interesting, to make the Android do more interesting drawings. And so the idea behind a draw button and the corresponding draw procedure is to write our own custom procedures and then plug them in here. Okay. So if I click the draw button now, it's giving me a message. Okay. Let me do that again. It's telling me to get me to draw, you have to define the draw procedure. All right. And so
Mhm.
that's kind of what we'll be doing today. Right? It's doing nothing else, right? It's not drawing. The Android man is just where he was. And so we will start writing the draw procedure. So if we go to procedures, I have already written some minimal code here. So draw eyes, draw 20 by 20. So this procedure draws a 20 by 20 square. So if I go to the procedures drawer and grab that procedure, I'm going to disable the notifier. Okay, so that means this block won't run. And then I'm going to call the procedure that I already wrote to draw this 20 by 20 square. And just to show you what happens now, I click on draw and it draw that little square. It drew that little square. Do you see that? It made that little square. Yeah. And it's a tiny square. So if I hide the Android dude, you can see the square a little better and show the Android dude. Yeah. So I'm going to delete all the code as we always do. I mean, the custom code. I'm not going to delete all the code. And we'll just write our draw procedure from scratch. Okay. Delete everything here. Yeah, delete this too. Delete this too.
All of this code is in the classroom. Is that
Right,
correct?
right.
Okay.
Yeah, I have not posted it there yet. I'll post it before tonight. Okay.
Okay.
Yeah. All right. So as we saw, now we are back to square one. So we are starting with a clean slate. Now when I reset and draw, let me enable the notifier. Yeah. Now when I click draw, it again tells me to get me to draw, you have to define the draw procedure. And so I'm going to write a little procedure we are starting simple. So let's write a small procedure to draw a 20 by 20 square. So how would we draw this 20 by 20 square with just the user interface? We would go forward 2 times. So I would press the forward button 2 times. Each step takes me 10, let's say 10 pixels in the forward direction. Then I would click right. Then I would click forward again 2 times. Then I would click right, then forward 2 times, then right, then forward 2 times, and then right. Yeah, makes sense. So this is how I would do it using the user interface. But we're going to write a small program to do exactly that. So what we'll do is first let's grab an empty procedure. And let's call it draw 20 by 20. So I'm just going to name it draw 20 by 20. Let's assume each step when I click the forward button, let's assume each step is 10 pixels. All right. So 20 by 20 is basically 2 steps, right? So 2 steps, each side of that square is 2 steps long. And we wanted to step forward 2 times. Which procedure would I use to do that? So looking at all my procedures here, call forward. Okay. So if I do just that, then in this procedure, the Android dude is taking 1 step forward and drawing a line as it does that. So I wanted to take 2 steps forward, then turn right, because this is a square. So we call turn. And now take another 2 steps forward, right? So lots of repetition here, right? Lots and lots of repetition. And again, turn right. Okay, so call turn, that's what it does. It can only turn 90 degrees to the right, yeah? And then we'll take another 2 steps forward, and we are getting there. Call forward, and then turn right. Wow, so much repetition, right? And another 2 steps forward. Let's see how much have we done so far. 1, 2, 3. So square has 4 sides. So just one more side to draw and call forward, and turn. Right? And if we've done this right, then this should make the little Android dude draw a square when we press the draw button. Yeah, there's just one little thing to take care of, which is in the draw function. Now I need to call this draw 20 by 20 procedure. So this 20 by 20 procedure that we just created, is now available in the procedures drawer. Let's grab that and stick it in the draw function. Okay. So now when we press the draw button, this is what's going to happen. It's going to draw a 20 by 20 square. Shall we give it a try? So here we go. I'm broadcasting the screen of my phone. The code should have updated. I click on draw and there I have a 20 by 20 square. Was there a question in the room? Okay.
So you just created the draw 20 by 20 and
Mhm.
didn't you have to add what we see on the screen? That's the whole procedure that you just wrote out. Is that correct?
That's right. That's
Okay.
right.
All right.
And we gave it a name to draw 20 by 20.
Mhm.
And then we used that procedure from the procedures drawer and pulled it into the draw procedure. So this draw procedure, which is what happens when we click the draw button, all right? This is just a template, right? And we can stick anything into this if we want, right?
Okay.
Yeah. And yeah, so the exercise that we want to do here is, you know, we would perhaps maybe let's think about this square that we just drew here as one of the eyes of a face. Yeah. And we'll draw another square of the same size next to it. So those would be two eyes. And then we could draw a bigger square that is the face with two eyes, and then a nose, which is a triangle, and so on and so forth. But for now, we are just going to draw another eye. Okay. So what we'll do is we'll go back to the blocks and we'll keep building on what we have just done, right? So now we have a procedure that can draw a little square, a little 20 by 20 square. And now what I want to do is I want to draw two of these, you know, so those are the two eyes of the face that we are thinking about, right? And I clearly, to draw two eyes, I'm going to need to call the draw 20 by 20 procedure twice, right? So I go back and draw another one. And what is this going to do? Let's see. Now I'm calling the draw procedure twice. I'm resetting, I'm clearing the canvas. Now when I touch draw, it should draw two squares, right? So I click on draw. And what happened? There is just one square. So let me hide the Android dude. There's just one square. Didn't we draw two? So what happened? So who can tell me what happened here? Yeah. So
On top of, I'm sorry.
yeah, that's right. Excellent, excellent. Right. So one is on top of the other. So we need to separate them, right? And so how are we going to do that? Well, we already have all the procedures that we need to do these primitive steps. So call forward. I think I'm going to need one more because when I drew the square, there were two call forwards, right? So yeah. So in this exercise, I'll keep asking you what do you think will happen next. And so think what should happen now. And then when I actually click the draw procedure, compare your answer to what happens and see if there's any difference or what happened is exactly what you predicted. So I'm going to hide the Android man. Right. Yeah. Okay. So what happened here, right? So now we have two squares. Yeah, it's looking like spectacles that are turned on their side, right? We also have this line connecting these two squares, which we did not want. We wanted two eyes, right? And so how are we going to do that? Do we have what we need to do that? So what we want to do here, let's think about it, is once the first square is complete, we want to lift the pen, right? We want pen up, then it moves forward, then pen down, and then it draws the second square. And so what we'll do now is we'll grab the procedure, we'll keep modifying code, we'll keep building on what we have already coded. Now I'm going to grab the pen up just after the first square is done, right? And then forward. And now we are ready to draw the second square. So before we call the second, let me just maximize this, yeah. So before we call the draw 20 by 20 second time, I'm going to get the pen down again. All right. So here's the pen up, here's the pen down. Right. And what do you think this is going to do now? Yeah. Sorry. Back here. The screen goes blank every time, and then I have to log into the phone. Okay, there we go. Reset. So now when I touch draw, what should happen? All right, let me hide the Android dude. There we go. Okay, so now it is drawing two squares the way we wanted. All right. And to wrap up this part of today's session, so this is the first of three parts. What I'll show you is how when we write code like this, it is usually, so now let's see what we have done, right? We took procedures that are already available to us, that are in a sense like prefabricated components, right? We took these procedures and we used them in our own procedure called draw 20 by 20. Then we used a draw 20 by 20 in another procedure. So usually when we call draw, we just want to give it one procedure. That would be a good programming practice. So I'll create another procedure here, and all this code that was inside draw, I'll pull it into that. And this one, I'm just going to call it draw eyes. Yeah. And usually when we write a procedure, what we have in mind is that this procedure will be called over and over, right? I don't know if we really have that opportunity for draw eyes, but in this case, we'll just put all this code into draw eyes just to keep our program neat and tidy. Yeah. So when we draw a face, we'll draw two eyes once and that's it. So usually that's the reason why we make a procedure. So when we make these procedures like forward, forward, turn, they're being repeated and used so many times, right? And if I was to just go to the procedure forward, just making a point here about reusability of code, then all this code that goes into just one forward step, I would have to have all this code repeating over and over and over just to draw a 20 by 20 square. Instead, I put all that code into a forward procedure. So that makes drawing a square easier. And now I take the drawing a 20 by 20 square into another procedure called draw eyes. And then I take the draw eyes procedure and put it into the draw procedure. So typically when we work with algorithms, this is the path that this is the journey that this is what our coding journey will look like. We'll have lots of procedures that we will draw into our own procedures that we will use in other procedures that they will then plug into other procedures. So you see that sort of a hierarchy will develop in our code. And that is how we want to write programs. Okay. All right. So just wrap this up. Here is draw eyes, which is freshly minted. So we just created it. It appears here. And now all we've done, we haven't changed the functionality a bit. We've just tidied up our code. And one more time, log in here and reset, draw, and show. And hide the Android dude. Okay. And now if I keep, you see, if I keep touching draw, it will just keep repeating this process. Yeah. So it's the advantage of writing a procedure. Okay. Any questions so far? All right. So let's move on from this.
The draw eyes, I do have a question. The draw eyes, how did we just change the name from draw to draw eyes?
Yeah, actually there are three procedures here, right?
Okay.
So draw 20 by 20 and draw eyes. Yeah.
Okay.
And when we create a new procedure, we go to the procedures drawer, we grab this template, right? And we can create as many procedures as we want, right? And in the next section, we'll be doing that, right? And we can give these procedures descriptive names, and we can give them any names we want, right? So if I had a procedure to draw a face, then I would pull all the code into draw face, right?
Okay, they're just the naming that you used. Okay.
Correct. Correct,
I get it.
exactly, right? And once I create draw face, then I go to procedure drawers and I'll see draw face here somewhere. You see it here? Draw
Mhm.
face, here it is.
Draw
Now it won't
faces.
do anything because there's no code in there, right?
Mhm.
And in the next phase, we'll be writing lots of procedures to draw triangles, circles, squares, polygons, right? So colored polygons, so what have you. So yeah, but this one is empty, so it will not do anything, right? But each procedure we create will just appear as a new block in the procedures drawer. That answered your question?
Mhm.
Yeah, so I'll just
Yeah.
delete these. Yeah, and so the kind of interesting thing we've done today, which we haven't really done so much before, was use procedures inside of procedures, okay? The only thing to be careful about is not to use the same procedure inside the procedure. So that's called recursion. So if I call draw inside draw, okay, and this will go into an infinite loop, okay, and then the program will basically crash when it runs out of memory, or it will basically keep running. If it's not using any memory, it will keep running forever, and you'll wonder what went wrong. So accidentally, if you put draw anywhere in any of these procedures, right? And then we are calling draw inside of draw, either directly or indirectly, it will cause the program to hang. And
Okay.
these kind of things are what cause bugs in programs. So usually it's a good idea to give our own procedures a very descriptive names that are very different from each other. So here, draw 20 by 20, draw eyes, they all kind of sound similar, right? So it's usually a good idea to give them names that sound very different. So we avoid calling the same procedure inside another. So it will not give you any error, but when you run the program, it will just hang. It'll cause
Okay.
the app to hang, all right? So, all right, let's move on to the next one. So to set the stage for the next one, so there are a couple of from a computer science standpoint, there are a couple of drawbacks to the way we have written these procedures right now. Yeah, can you guess what those are? So one of those is, with this procedure, I can only draw a 20 by 20 square. What if I want to draw a square of any size? So I would want to parameterize my procedures. When I say parameterize a procedure, that sounds like a mouthful, but it's the principle is really very writing code in a way that is very easy for the developer, for the coder, right? That is for you, right? You and me. So we would want to write the procedure in a way where we can pass it a parameter. That's why we say parameterize it, right? So we would say, I want to draw a square of any size. Yeah. But I will tell you what size. Here it is fixed at 20, right? So if I wanted to make it 40 by 40, then I would have to, sort of write another procedure to draw 40 by 40. And so that is a very rigid way of going about writing our program. So the first thing we want to do, the first problem we see here is this is very rigid. And so we want to parameterize the procedure. The second problem is that we are repeating code a lot. Yeah. And you remember the DRY principle, DRY, do not repeat yourself. So we can write our code in more elegant ways. We don't have to repeat these blocks all the time. It's very boring to repeat code in this way, right? So we'll fix these problems in the next session. And we'll also we'll also start doing more sophisticated graphics than what we have already done here. Go to my projects. And so this one is a logo with parameters. Like the look and feel of that is exactly the same. There are the same buttons, the same Android dude. Nothing has changed as far as the screen is concerned. And in the code, also more or less it's the same. It's just the parts that we will write that will differ. Okay, and so to just kind of show you how far we're going to go today with this one, just going to demo this one. So back to my screencast. I think my screen disconnected. So we go back there. Yeah, this keeps happening all the time. Disconnect. All right. Back here. Okay, let's go back to our code. And this time when I click on draw, it's going to take a little, it's going to take a few seconds. Where, there, what happened there? Okay. So what do you think of that? Huh? So I'm going to reset, click on draw. And this time the Android dude is going to draw all of these circles and make this beautiful pattern, right? And this is really to illustrate algorithms. So when we started by talking about Dr. Papert and Professor Papert and logo, and this is the type of illustrations that would program the turtle to draw, right? So how do we go from that tiny little 20 by 20 square that we were drawing to something like this? And the whole purpose of this exercise is just to illustrate algorithms, right? So I don't know if it is useful to draw, make drawings like these. What is the purpose of it? It really doesn't have any purpose. It's just to understand how we build algorithms, starting with small building blocks and then using those building blocks in more complex structures until we have what we want. All right. So it's just for illustration purposes. So the code is already there, but as we always do, I will delete it. I will move it to the backpack and then we'll start from scratch. So I think this is already in the backpack, if I'm not mistaken. Yeah, it's there. Whatever is there, we'll work with that. So I'll delete this, draw bangles, delete this, draw triangle. And as I'm deleting this, just think about what would we do differently about drawing the square. Okay, I'll leave these global variables there. Not hurting anyone. Right, there we go. Yeah, delete the procedure. So everything is gone, right? Everything is gone. Draw polygon, clean up this as well. Delete, 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 delete. Yeah. Okay, so now we are back to square one. Enable this block and go back to the app, log in again. All right, here we go, reset. And so when I click draw, I get again this notification. So to get me to draw, you have to define the draw procedure. So everything is back to square one. We'll disable this block. And one little difference here is now the building blocks themselves are parameterized. So when I go to the procedures drawer and look at the forward procedure, okay? Previously, it was just a block. So now it's a block that wants to know how many pixels, right? So this forward procedure has been parameterized. So I can go forward. I can change the step size. And when I say go forward, I can set the step size by passing it as an argument. And the step size is measured in what units? Pixels, right? When you look at the turn procedure also has been parameterized, right? And the parameter that it accepts is degrees. So I can tell it, where previously we were calling turn and it would turn to the right by 90 degrees. Now I can tell it how many degrees to turn by, yeah? And we're going to need both these anyway to draw our square. So let's go to the procedures drawer and grab a blank template. And let's call it draw square, okay? Now, unlike before, this is going to be a procedure that can draw a square of any size. So we'll pass the size of the square as a parameter, okay? So it's called X by default. Let's give it let's just change the name of the parameter to size. So we know it's the size of the square. And what are we going to do here, right? We're going to call forward, turn, forward, turn, forward, turn. And so instead of repeating all that code, I'm going to do this in a slightly improved version where I'm going to go to the control drawer and use a for loop. Okay. So you see this for each number. Let's grab that. So what the for loop will do is it will iterate. Iteration means just repetition, right? So it will repeat whatever code we put in here where it says do. And how many times to repeat? So we instructed how many times to repeat in the following way. We tell it to iterate over these numbers starting from 1 up to 5 by 1. So this is all customizable, right? So we can configure the behavior of the for loop. And at each step, so it'll start from 1, do what's in here. Then once it's done, it will come back and increase 1 by 1. So then what do you have? You have 1 plus 1 is 2. Another time, do whatever is in here. Another time, and then another time, and then another time, until it reaches the number 5, and then it stops. Okay. So we use the for loop to just execute code repetitively to deal with repetitions. So we want to go forward and turn, forward and turn, forward and turn 4 times, right? Because we're drawing a square. So I'm going to change the 1 to 5. I don't need the 5, I need the 4. So I'm changing the for loop. I'm changing the behavior of the for loop to go from 1 to 4 in steps of 1. And each time, what is it going to do? It's going to go forward by how many pixels? So that's what I have in the size. And it's going to turn by how many degrees? Who can tell me how many degrees? 90 degrees, right? So that's a right turn, okay? All right. And so now we have a new procedure and we've fixed some of the problems we had before, right? Chiefly now we can tell it to draw a square of any size. And now we're not repeating our code over and over. We have used a for loop to do that repetition for us. All right, makes sense? Okay, so companion has disconnected. That happens from time to time. So I'll go back to the connect menu, click on AI companion, get the QR code, go back to my phone. All these steps become second nature after a while. Log in. All right, so now go back to the companion app here. Scan the QR code. Do what we've done many, many times. Okay, I think the QR code is partly hidden. There we go. Now I have the app back on my phone. Coming. There we go. And this time when I hit draw, what do you think is going to happen? Oh, what did we miss? we made the procedure and we haven't called it in the draw procedure, right? So that's easy. So let's go to our procedures. Where is the procedure that we just created? Draw square. There it is. Yeah, and now you see it is asking us for the size that we want the square to be. And this time let's draw a bigger one. Let's go to 40. Okay, go back to the screencast. There we go. Hit draw, and there's our square. Okay. Let's play around with this a little more. Maybe let's verify that we do indeed get squares of different sizes. I'm going to go to procedures drawer, grab draw square one more time. What size do you want this square to be? 60. Okay. We draw. This is not necessarily the most interesting thing, but let's just for testing purposes, right? Let's draw 3 squares, 20, 40, 60. So what do you think this will do? So just think about that while I draw. And there you go. You have 3 squares, right? In this nice pattern. So you can already see how parameterizing a function and using a for loop is making a difference, right? So as a thought exercise, now what I'd like you to do is to think about this, right? This is better than what we had before. And now we also want to be more ambitious. What if I can write a procedure to draw any polygon? It could be a square, it could be a triangle, it could have 5 sides, 6 sides, 100 sides. Can I write a procedure to draw a general polygon of any size? Right? And as we start into that, let's start by thinking about how would we write a procedure, right? So to think about a general procedure to draw a polygon with any number of sides and of any size being the length of one side in pixels, okay? So to draw such a polygon, let's practice drawing at least one other shape other than a square, one shape other than a square. Let's go with a triangle, right? So just think about this. What would the procedure to draw a triangle look like, right? So let's go to the procedures drawer. And first, let's just grab an empty template. So the game I'm playing here is if we know how to draw a triangle and we know how to draw a square, then we probably know enough to start thinking, well, how do I generalize this to a polygon? All right. So I'm going to call this draw triangle. Right. And yeah, let's also give this a parameter for the sides. This is going to be an equilateral triangle, right? So all angles are 60 degrees. I'm going to give it a parameter size. Okay. And again, whatever I do, I'm going to have to go forward and turn. So let's grab those anyway. Go forward and turn. All right. And I'm going to need a for loop, right? Because I'm drawing. Why am I going to need a for loop? Because I'm going to be drawing multiple sides. All right. So now that we have the ingredients, let's think about making our procedure. So a triangle has 3 sides. So clearly I want to draw 3 times. So instead of 5, we'll change this to 3. Right? So for each number 1 to 3 in steps of 1. So I'm going to be doing something 3 times. Now, what is it that I want to do? So I want to go forward and then I want to turn. So the remaining question is, how big of a step should I take when I go forward? That's easy. That's the size, right? So grab the size, which is a parameter to the function, the procedure. I'm using function and procedures as synonyms. In most programming language, you would call, like JavaScript, Python, you'd call these functions. Here we call them procedures, but they mean the same. The next question is degrees, right? So to refresh memory, this turn function accepts a parameter and we can tell it how many degrees to turn. So how many degrees should that be? So the rule here is, well, it's an equilateral triangle. So that's going to be each vertex is 60 degrees, right? We want to have a quick look at that. You can just Google it. Equilateral triangle. You just pull up an image. Yeah. So each of these, each vertex, it has 3 vertices and each vertex is 60 degrees, right? This is a good one, right? 60, 60, 60. So that means the Android dude has to turn 120 degrees each time, right? So because the internal angle is 160 degrees, so the external angle is 120 degrees, all right? So let's just go with that and see what happens, okay? If we need to fix it, if we need to change it later, we'll change it. So the turn disconnected again. That's fine. I'll come back to this in a moment. I'm going to go to the math drawer and grab 120 degrees. Let's just see what happens at 120 degrees. Now I'm ready to plug this for loop into the procedure. And now I have a new procedure, draw triangle. Let's find that procedure. Draw triangle, and it is. Let's go back to draw. I'm going to disable all these. I no longer want to draw squares. I'm going to disable all of these. clean up my code, okay, and call the draw triangle procedure that we just created inside the draw procedure. And what size do we want to give it? Let's make it like, say, 25. Okay, so what's going to happen now? So just think about that while I connect and pull up the app again. Just think about what that triangle is going to look like. Is it going to be on a side? Is it going to be with the vertex pointing down? Which way is it going to point? Just think about that. Work through it while I just connect back to my phone. Okay, the app is coming up. There it is. Touch. Why are you moving around, buddy? Okay, what's it doing? There it is. Okay, one moment. Okay, so draw, and there it is, right? So it's a small triangle. So I'm going to hide the Android dude, and there it is, a triangle. Okay, so it went forward by 25 pixels, turned by 120 degrees. So 90 degrees would be a right turn. 120 degrees means you keep going after the right turn and turn another 30 degrees, right? So then it went forward. It turned 120 degrees, went forward, turned 120 degrees, went forward. So the rule here is that the math here is that, when you're drawing a shape with n sides, then the angle that you want to turn by is 360 divided by n, right? So for a triangle, it's 360 divided by 3. For a square, it is 360 divided by 4. For a pentagon, it's 360 divided by 5, and so on, okay? So now we are ready to write a procedure to draw any shape. Let me just do a quick check of the time, okay? I'm going to have to stop in 15, 20 minutes. And I'm going to write this procedure, and then we'll sort of call it a day, okay? So this is going to be draw polygon. Hope you are following along. Otherwise, I'm going a little faster today. Otherwise, just stop me if you have a question. There we go. Much of this is going to be the same as what we have done so far for a triangle and a square, except that now this function is going to accept 2 parameters. Okay? Because first we want to tell it how many sides. It's a polygon, right? So we need to tell it how many sides. And then we need to tell it what size. What is the length of each side? That's what we are calling the size. Okay? And this time, also I'm going to need a for loop. So let's grab that. I'm going to need to go forward and turn no matter what I do. So I'm going to go to the procedures drawer, call forward, turn. Where is turn? There it is. Yeah, and now all that's remaining is to figure out what do we put in these, how do we customize the behavior? So the for loop, let's start with that, right? So we're going to, for a polygon with n sides, n for new, we will be drawing a line n times, correct? So instead of 5, instead of a hard-coded number, whether it's 3 for a square or 4 for a 3 for a triangle or 4 for a square, we are going to pass it the value of sides. We're going to pass it the value of the parameter, right? So we got that figured out, right? And we go forward. We still want to go by the step size that's specified by the user. So we just get the size, which is the second parameter passed to the draw polygon procedure. And the turn, that's the last thing we have to figure out. And as I just shared with you, and you probably already know, the math here is just 360 divided by the number of sides. So let's go to the math drawer and grab the block for division. And then 360 is a constant, right? So 360 and divide by the number of sides. So get sides. And that looks like it will do the job. Yeah. Let's make sure we understand the logic of this. So I'm drawing a polygon. I tell the procedure how many sides and what size. Then depending on the number of sides, the for loop will iterate that many times. And in each iteration, it will draw a line of the specified size, turn by the correct number of degrees, and then draw again. And this goes on and on. Makes sense? Right. So now if you've done this right, then we have a procedure that can draw any kind of a shape, any kind of a polygon shape. So let's disable the triangle draw procedure. Let's clean up our code a little bit. And let's go to the procedures drawer and draw polygon. There it is. Plug it into the draw procedure. We need to tell it how many sides. So what do you want to draw? A hexagon maybe? 6 sides. And what size should it be? Yeah, let's say each side is 15. So that number. Connect to the AI companion. Let me just share my screen. From there it is. I need to reconnect. No, not this one. This one is already connected. Yeah, go back to the companion app, scan QR code. There we go. Scanning the QR code. App is coming up on my phone. There it is. And so this time when I touch draw, there's a little hexagon. Okay, touch draw again, hide the Android tool. There it is. Okay. And so now let's change the size of this to something bigger. Make it 36 or something. Okay. Reset. I touch draw, and there it is, bigger hexagon.
So the size relates to the number of pixels, right?
Correct. Because the size is, we are passing it to the forward procedure.
Okay.
And yeah, so each time it goes forward, turns, goes forward, turns, goes forward, turns. So forward means go in whatever direction it is, the Android dude is pointing, right? And the forward procedure, we tell it how many pixels to that step size should be, right? The stride length, if you will, right? So it's the size of pixels. So each side is now 35 pixels, okay? Each side of this hexagon or triangle or square, whatever we're drawing, each side will be whatever size we specify. That answer your question?
Yes.
All right. So one last thing I'll kind of do here today is, so yeah, so these are all polygons. So how do I draw something like a circle, right? So it turns out that in computer programming, we don't draw a circle. That might sound strange, but actually what we draw as a circle and what looks like a circle is a polygon with many sides. Let's say 60 sides or 100 sides or 150 sides. So we already have a procedure, right, to draw a polygon. So we can just use that. So maybe let me convince you that a polygon with many sides is actually looks like a circle. Okay. So what number do you want to pick? Like 66? Is that big enough? Let's try that.
Mhm.
So I'll go back to my screen. Yeah, there we go. Reset. So now I instructed the procedure to draw a polygon with 66 sides. Oh, so it went out of the screen. So it's too big. Let's draw 6. Okay. Okay. Does that look like a circle to you? Reasonably? Yeah.
Sure does. Mhm.
Yeah. So this is how we draw a circle. So we could actually just write a procedure to draw circles. And inside, just call the draw polygon procedure. We will just give it an input, which is size. So typically we would want to give it radius, right? But then we would have to work through the math of what is the relation between the, what is the relation between the side of the polygon and the radius of the circle, right? And so I haven't worked that math out, but we can do that, right? It's just a matter of working it out, and then we would be able to give it radius. Instead, I will just continue to give it a size parameter, which is the size of the segment that it draws, which is basically the side of the polygon, right? But yeah, just know that what we would desire eventually is an implementation which has a radius instead of the size. Okay, and in here we'll just call the procedure for polygon, draw polygon, and we'll hard code the number of sides. Let's make it 90 sides. So the more sides there are, the less jagged it will be, right? And yeah, the size it will still accept from the user. I wonder what this will do. Let's disable this and let's pass it procedure to draw a circle. What do we call it? Draw circle. Should be somewhere here. Wow, added so many procedures.
There it is.
Yes. Clean up my blocks. Size. All right. This should be reasonably small, so it fits in the canvas. Okay. All right, let's do this one more time and see. Screen coming up, reset and draw. So what's happening here? It's bigger than the size of the canvas.
Mhm.
So that's why you have that interruption. So let's just make it smaller. Reset, draw. There you go. You have a circle. Okay. Now what you could also do is draw circles of different color. Right. You could change the thickness of the line. You could change the color of the line. Let me show you how to do that. So I'll have to wrap up in 5 minutes. I don't want my little girl to miss her shots. So there we go. Okay. So what we would do if we wanted to draw these circles. So far, all the shapes that we've drawn, they've been black, right? So Canvas has a property called paint color. We've used it before in one of the apps. I can't remember which. Canvas has a property for all the graphics that we draw on the canvas, paint color, line width. So what we would do is pretty much what we have done until now, with the addition that we set the canvas properties, paint color and line width, to add color to the shapes that we are drawing here, right? So the rest of it, so this is a method called, simplify this a little bit and delete the notifier. That was for debugging purposes. Yeah. So just compare the code here with the code here. Where is the polygon? There it is. Yeah, here. Here we go. We just pan the canvas so you can see it properly. Okay. Just compare the code here, draw polygon, with draw polygon Technicolor, right? And all I'm doing is I'm just drawing in color. So I've created a local variable called palette, and I've defined some colors. C1 is yellow, C2 is red. And what I'm doing is I'm drawing a multicolored circle, right? So every step that the Android dude takes is in a different color, right? And to change the color, we set the paint color attribute of the canvas. So each time I'm using a different color. So each step in the for loop, I'm using a different color. You could also tweak this procedure to draw a polygon of one color and pass the color as a parameter. Or you could draw it in red and fix that color over here. You could do this in so many different ways. So I'll leave that as an exercise to you. I thought perhaps for demonstration purposes, what makes sense is to do the most complicated case, which is draw a single polygon which is multicolored, right? Let's just see the behavior of this function, and then I'll explain the code one more time, and then we'll call it a day. So I'm going to disable this. So the way I have gone about today's session is the draw procedure has everything that we did. So when you go back, you can just enable the procedures that I've disabled. You can enable, disable however you want. So that's why I didn't delete them, right? So this is the last step we'll do today, called draw polygon in Technicolor. Clean up blocks. So how many sides? Let's make this a multicolored circle, right? So if we give it a 66 sides, then it's definitely going to look like a circle. And then, you know what, let's start a little simpler and then work up from there. So let's just draw a hexagon, or let's draw an octagon. We already did hexagon. All right, and let's draw an octagon of size 6. Let's see what this does. I don't even know if it will work. Okay. Reset. Oh, wait. Oh, okay. Hang on a second. The hardest part of this is just this connecting and disconnecting. All right, reconnect. Okay, MacBook screen mirroring. It's so nice though that I can share my phone in this way. Right, there it is, it's back. Okay, all right, so reset. Oh, did we not, we called a draw, right? Okay. What's happening now? Okay. Draw. Nothing's happening, so I'll disable that. Just make sure that I can draw my circle. Enable the previous one. Yeah, so it's drawing the circle. So that is cool. Now, enable, where is enable? Okay, there we go. All right, so let's debug this. Go to draw Technicolor polygon. Oh, okay. This is what is going on here? Okay. Draw. Okay, got it. You just had the wrong name of the method. Earlier, when I moved the block to the backpack, I created duplicates, unfortunately. But yeah, that's all it is. Okay, glad we got that sorted out. So reset draw. Okay. Accept the argument. Wonderful. Error message. All right. Let's just go back here and see. It's probably something minor. Thanks. Draw polygon sides. Size. Go forward. Okay. The operation divide. Okay. Sides and size. Sides. And okay, C1, C2, LW, and size. Okay, from number to get sides by 1. Looks all right to me. Do you see any error? There's no error here also. So what is going on? The operation your divide cannot accept the outcomes. Let me try one more time. The error message went by before I could see it.
Yeah, I couldn't read it either.
0 false.
Let's see.
somewhere I have messed up. That much is clear. Oh God, it was just such a simple thing. This had come unplugged. Even now it's not drawing. Okay, I'm going to have to take this offline because I have to close today's session and take my daughter to her vaccinations. But do you see any error in here? Perhaps if you could so have a look at this and help me out. Now there are no warnings and there is no error also. It's still not drawing. So it's very adamantly refusing to draw. Have I used the right method? Draw polygon technicolor. Okay, that's right. Is my pen down? Well, clearly it is because I draw a circle. That works, right? It's okay. Is my canvas the right canvas? Canvas 1, yes. Line width is 4. What is number? Oh, number is here. Okay, from number 1 to get sides. Okay, I'm kind of going to need to call a timeout on this one. Okay, so it did something.
Goes out of bounds.
Okay, we just changed. It is actually working. I don't know what was wrong before. I changed the size to 3. I said draw. Okay, there we go. All right.
Oh,
So
so it's the technicolor. Okay.
yeah. So there it is. So I'm going to make this a little bigger. 4. Okay, so there it is. So this is a technicolor circle. So what you can perhaps see here is that the same circle is all the colors from yellow to red, right? And I have no idea why it threw that tantrum, but yeah, we're back in action. And so, yeah, what is happening here is I'm doing what I was doing before. Again, let me explain this code one last time. In terms of how I draw the polygon, it is the same as we were doing before. There's a for loop, and inside the for loop, there is a forward and a turn. Yeah. So the step size and the turn angle is computed in exactly the same way. The parts that I've added are really the parts to do with the coloring, using the paint color and the line width attributes of the canvas, and then computing a new color every time. Okay, so colors can be computed the same way as any other number. So what I have is yellow color is a number, red color is a number. So although what I'm seeing here is just a color, yellow, behind the scenes, it's a number. The computer represents every color as a number. You could think of it as a combination of red, green, and blue. And red is a number between 1 and 255. Green is a number between 1 and 255. And blue is a number between 1 and 255 in red, green, blue space. So that is why we can actually do math on numbers. And what I'm doing here is I'm just telling it, go from yellow to red in steps of 1, right? So each time it's computing a new color, which is again from to in steps. I've divided from yellow to red in the number of intervals equal to the number of sides of the polygon. So that is 90 over here, right? So each little line that gets drawn in the for loop over here is of a incrementally different color, right? And that is how we get this colored circle here. Okay. Now what you can try doing is have the Android man move, turn a little bit every time a circle is drawn. So in the call procedure itself, we will go to procedures and call turn, maybe turn by 5 degrees or something like that. And then you can get that beautiful spiral graphic that we were having before. Okay. Let's turn by 10 degrees every time. Draw polygon turn. Yeah, so we're going to have to write a for loop. Polygon turn. I'll just show you one part of it and then I'll have to drop off. Okay. So duplicate. All right. So, okay. Do you see it drew 2 circles now? And so at the beginning of this session, when I showed you that beautiful drawing with about 36 circles, all forming a nice, pretty image. So this is what I had in a for loop, just calling draw polygon and turn over and over again in a for loop. And I'd written another procedure to do that, which is in the backpack. I'm getting a little nervous because my time is up. I need to run, but here it was called draw bangles. Right? So all I was doing is in a for loop, I was calling draw polygon now every time. So let's just disable all of this since we have come so far. Go to procedures, draw bangles. Bangles are what we call them in India. The women wear them on their hands, right? They're very colorful. So what this is going to do is now it's going to call draw polygon technicolor. So it's going to use this draw polygon technicolor method to draw a circle. Its size. Yeah. I have hard-coded the number of sides to 60 because that gets a reasonably close approximation to a circle. The size is whatever we pass to it. So let's pass a size of, let's say, 4. Now it's going to draw a circle multiple times, turning by 15 degrees every time. Kind of rushing through this a little bit, I'm sorry, but yeah, reset, draw. And this procedure takes a little time to run. And then we end up with this graphic, all right? Sorry, I had to rush through that last bit, but hope you could follow along. If not, the code will always be posted on the Google Classroom. And do you have any questions?
How do we get access to the Google Classroom?
Oh, to the Google Classroom. You can give me your email and I'll add you to that. Otherwise,
Okay.
you can just join in with the code. Let me just add you right now before I leave.
Okay.
So I take it you haven't been to any of the previous classes then?
No, this was my first one.
Oh, okay. Okay, no problem. We have all the video recordings of the classes from before also.
Okay, great. Thank you.
That's the classroom. Add you right now when I. So this is the Google Classroom. You can see it, right?
Yes.
Yeah. And just going to add you people. Add here. That's you, right?
Yes.
Send you an invite, and then once you accept it, you'll be added. Okay.
Okay, great. Thank you so much.
Yeah, you're welcome. And Were you able to follow along today, despite not having?
Yes,
Okay.
mostly at the beginning, but towards the end, a little bit, it might be something I just have to play with.
Sure. Okay. It's good that you could follow most of it. Towards the end, I also had to rush it a little bit. I apologize because, I have a hard stop today and I'm already
Yes.
overdue. I apologize. But everything
So-
is here in the Google Classroom, and you can, as soon as I get the videos, it takes me about a week to get the video recording, and then I post it here in the stream, and you can get it from there. All right.
How long do we have access to the classroom, Sandra?
Okay, so this is it for today, and
Okay.
once again, it was fun hanging out with you. So this is the last class in this series. Okay, so technically we are done today, and that doesn't mean that we are done though, because I will continue to participate in the classroom. And as you apply what you've learned to building your apps, and when you feel stuck somewhere or need any help, I'll be monitoring the classroom, and I'll get some time with you one-on-one to help you out with wherever you are. Yes, but in terms of this course, this was a 10 series course, and today was the 10th in the series. So we are done, right? But feel free to participate in the Google Classroom. And this is just the beginning of our journey, not the end of it, right? So
Yes.
let's approach it in that spirit.
Well, thank you so much for your time today, and I appreciate it.
Yeah, you're welcome, Angie, Lutz. Take
Thank
care
you.
now. Have a nice
Thank
evening.
you. Bye.
Okay.
Bye.
Have a good day. Bye-bye.
You too. Bye.